Okay, let's look at the lab right up. So the first part of the lab was with the concave lens, and the second part with the convex lens. You should have filled in from your lab your table 1, table 2, and table 3. Okay, so you're going to reproduce all of those in your results. You're going to rewrite, of course, the purpose. The hypothesis, I guess I forgot to suggest something. So hopefully you predicted something, maybe about the focal length, maybe about what you expected to see in the cases. Maybe something about the concave lens, I'm not sure. Sorry, I forgot to tell you, but it should be an automatic that you write a hypothesis, especially when I give you the lab sheet. Unlike in physics when you're not always sure what the purpose is, because I don't always give you a lab sheet. Okay, and then of course you have to go through the procedure and rewrite it so that it's accurate for what we did and so that it's past tense and impersonal. All right, so then also under the results is going to be your questions. So that's what I wanted to take a look at because we already talked about the sources of error. So question 1 is, using table 2, summarize the characteristics of the images in each of the following cases. So here it wants the characteristics of the image that you found in each case. So was it real? Was it inverted? Was it bigger? Was it smaller? Was it between F and 2F, between F and the lens? Okay, so that's what it means by the characteristics for each of these cases. For number 2, for each of the real images you observed, calculate the focal length. So only for the real images, which should be these first 3, because you don't have any DIs over here for the case 4 and case 5. So for the first 3 cases, using the DO you wrote down and the DI you wrote down, calculate F, okay? So do your lens equation, 1 over F is equal to 1 over DO plus 1 over DI, and find your F for each of these first 3 cases. Okay, so that's what number 2 says. And then it says, do your values agree with each other? Well, like in theory, these values should be the same because the lens hasn't changed, which means the F hasn't changed. So once you find the 3 Fs, talk about whether or not they match, okay? Then number 3 says, average the values for F that you found in question 2. So average these 3. And then calculate the percentage error for each of the values found in number 2 as well as the average. So you're going to do 4 percentage errors, 1 for each of these 3 plus 1 for the average, by using your value for the F from table 1 as your actual value. So the F from table 1 is the one you found outside, and the one that you based these cases on when you were doing it in the lab. So using this as your theoretical value, and the F that you got for each of the 3 cases using this equation as your experimental value, you're going to do 4 percentage errors. 1 for case 1, 1 for case 2, 1 for case 3, and 1 for the average. Okay? So that's the first 3 questions, all to do with the convex lens. Question 4 has to do with the concave lens. So it says, plot a graph, of course on graph paper, and of course a full page graph, not this tiny little thing in the upper corner. So plot a graph of the image diameter, so this one, on the vertical axis, okay, and the distance on the horizontal axis. Then note it says, allow room along the horizontal axis for negative distances. So this time on your graph paper, you can't go all the way over to the edge. You need to leave some space on this side. Okay, and so you're going to plot your points, and they're going to be hopefully something like this. And then when you draw it, it wants you to extrapolate it back and find out this point on this back side. This point on this back side should be your F. And it's going to be in the negatives because this is a concave lens, and concave lenses are negative. Okay, so that's what it's saying. Draw a best fit line. In other words, don't play dot to dot, but draw a line, which I didn't just do, with a ruler that goes as close as possible to as many of the values. If there's one way off, you ignore it. and you extend the line back to the x-axis. Extend this line until it intersects the horizontal axis. The negative distance along the horizontal axis at the intersection represents the value of the focal length. What is the focal length? So it wants you to read it off the graph once you draw your line back. Then it says if your lens package includes an accepted focal length, calculate the percentage error. And your lens package did. I didn't tell you because I didn't want to bias you, but both of your lens packages had a focal length on them. So when you come back in the next day after your test, I'll tell you what those focal lengths are so that you can do the percentage error. Okay? So that's the questions. Then, of course, your sources of error and how you would fix them, and your conclusion. And, of course, in the conclusion, you should talk about the cases. You should talk about your Fs. You should talk about the concave lens and the F down there. Okay? Plus whatever your hypothesis might have been and how cool the lab was. Okay? So that is the lab write-up. We will talk about when it is due, but obviously it won't be until next week.